Indirect evidence for the existence of atoms. Laws of chemical combination. Question 7. Nitrogen and silicon form two binary compounds with the following compositions. Compound 1 has a mass percent of nitrogen of 33.28% and a mass percent of silicon of 66.72%. Compound 2 has a mass percent of nitrogen of 39.94% and a mass percent of silicon of 60.06%. The problem asks us to compute the mass of silicon that combines with 1 gram of nitrogen in each case. So we'll start with compound 1. So the information that the problem gives us is the ratio of the masses of the two elements within each of the compounds. We know the ratio between nitrogen and silicon for any given mass of compound 1. It will be identical to this mass ratio. So the ratio of nitrogen to silicon is 33.28 to 66.72. Because these percentages add to 100, let's pretend we have 100 grams of compound 1. Whether we have 100 grams of compound 1 or 5 grams of compound 1, the mass ratio between silicon and nitrogen will be consistent no matter how much we have. So let's make a proportion because we know the mass ratio is consistent. So 66.72 grams of silicon over 33.28 grams of nitrogen. This is proportional to an unknown amount of silicon, that's what we're trying to find, combined with 1.0000 grams of nitrogen. By sight, we can see the left side of the equation is approximately 2, but using your calculator, x equals 2.005 grams of silicon, meaning 2.005 grams of silicon will combine with 1 gram of nitrogen to form compound 1. We can repeat the same method with compound 2. We know that the ratio of nitrogen to silicon for compound 2 will be consistent no matter how much we have. So if we pretend that we have 100 grams of compound 2, we can say that 60.06 grams of silicon combines with 39.94 grams of nitrogen. This ratio will be identical when 1 gram of nitrogen is combined with an unknown amount of silicon. And in this case, x is equal to 1.504 grams of silicon. So if you have a process that yields compound 2 and you have 1 gram of nitrogen, this will require 1.504 grams of silicon. It's also interesting to note that because we're using exactly 1 gram of nitrogen, the amount of silicon required in each case is the ratio of silicon to nitrogen in each of these compounds. To be explicit, 60.06 divided by 39.94 equals 1.504. This value is the ratio of silicon to nitrogen, and because we have 1 gram of nitrogen, we can easily determine by sight that we would need 1.504 grams of silicon.